Hello students, welcome to Nilagiri Degree and PG College YouTube channel. Today we will discuss about computer science data structure paper, representation of stack using arrays. In previous classes we have discussed what is stack, what are the various operations on the stack. We have discussed conceptually. Now today, how a stack is represented in a programmatically. How stack is represented in a programmatically. So generally, a stack can be represented in two ways. One is by using arrays, and another one is by using a concept of pointers and linked lists. So in previous class, initially we have studied that data structures are four types: primitive, non-primitive, linear, non-linear, static and dynamic. So if we represent a stack using array, that is called as a static data structure, static stack. If we represent a stack using pointers and linked lists, that is called as a dynamic data structure. Now let's discuss that. Data structures may be linear and non-linear, and data structures may be static and dynamic. Linear data structure is a stack and two. Stack may be a static, stack may be a dynamic. If we represent a stack using arrays, that is called as a static stack. Static stack. If we represent a stack using pointers and linked lists, that is called as a dynamic linked list. Dynamic linear list. So now we will discuss how to represent a stack using arrays. That means static stack we will discuss now. The third unit, third chapter, there is a concept of linked list. Before going into dynamic stack, we have to know what is linked list first. So after learning of this linked list, we can discuss about the dynamic linked list. So dynamic stack. So presently we will discuss about how to represent a stack using arrays. How to represent a stack using arrays. So generally, to represent a stack, we require a one-dimensional array. We require a one-dimensional array. We already studied an array is a collection of similar type of elements. That means a static stack is used whenever all elements are same type. All elements are same type. Either all are characters. That means if in a stack there are some elements are there. Either all are characters, either all are numbers, either all are floating point numbers, right? Either all are double type numbers, because they all are similar types, because we are using array. Array is a collection of similar type of elements. When you are using array to represent a stack, all the elements in the stack are of the same type. So generally, a one-dimensional array index starts from 0. Index ends with size minus 1. So that the elements are stored from the 0 onwards. The first element in the stack will be stored at the 0th index. The second element will be stored at the first index. Third element will be stored at the second index, and so on. When the stack is full, all the elements are filled from index 0 to size minus 1. So this is a way of representing a stack. So generally, when you are representing a stack using array, so stack ADT will be like this. ADT means abstract data type. ADT means abstract data type. Abstract data type. Abstract data type describes what are the elements, what are the properties in that stack, and what operations you are going to perform. Properties means variables required. So generally, when you are using an array to represent a stack, we have to declare a class for the stack. We have to declare a class for the stack, and there are the private members and public members. Private members and public members. The private members are, we are declare array, say integer a, integer s of, say for example, a given size is 10, or you can say that size is 100, whatever may we can take. Int s, so this s is a stack now. So instead of I am taking, instead of size taking 100, I am taking 10. That means the stack will be like this: 0, 1, dash 9 will be looks like this. Okay. We require a variable top. We require a variable top, integer top. So this is a variable required to know the position of the element. If the top value is 0, that means the elements are at 0th position. The topmost element is at the 0th position. The top element, top is equal to 1, that means the top element is 1. Next, if the top value is 2, that means the topmost element is at 2. The top wall, there is no element, automatically top value is -1. So this is a variables required. Next, we need some operations to be performed on this stack. We need to perform some operations on these two variables. What operations we can perform? First, we have to create an empty stack. For creating an empty stack, I am using a stack constructor that will take one parameter, say x. I forgot here, we need another variable also, say n. Here n is the size of the stack. So actually given 10, but I want to store only 5 elements. We have to take it. The n value always less than or equal to 10. For example, I give size I given 100. N value always less than or equal to 100. So that is the size. The maximum is 100. What is the minimum size? Stack in x. Next, another operation we need to perform on stack is void push operation. So the push means that we can insert an element into the stack. Whenever inserting an element into the stack, we need to specify what element you are inserting. That means the push operation will take one integer value. Why it is integer? Because the stack can store only integer values. Thus the stack data type is integer, so that you can insert only integer data types. For example, if it is a character, we have to give a char only. If it is stack, for example, data type is char. Star data type is char. That means we can store only characters in the stack. So that here also it must be char. If the stack data type is float, it can store only float values. So at that time also the push has to take float data type. Next, here it is always integer because here x is the stack size. The size always you can say that 10, 15, 16. You cannot say that the size of the stack is 8. It is not correct. So that the stack data type always integer. Even you cannot say that the stack size is 12.5. It is not correct. Always will say integer values only. So that here the stack creation also integer. The next one is while pop. So it will perform deletion operation on the stack. It is top, it is pop. Top is the topmost element, pop is a deletion operation. So here it will does not take any parameter because the pop always removes topmost element. Next, while display operation. Here display operation means, so display function perform the display the what elements in the stack. So the display operation display the elements in the stack. How many elements are there in the stack? What are the elements present in the stack? That has to display. So at that time we have to use the display operation. So we have to close the class. C language definition, class definition always ends with the semicolon. So these are the operations. These are the variables we require. These are the operations we are going to perform on the stack. What operation? We have to create an empty stack. For that I use the stack constructor. I am performing insert an element into the stack. So for that I am performing using the push operation. Next, we can remove an element from the stack. I am performing pop operation. Next, I want to know what are the elements from the stack. I am using display operation. So this is a stack definition. So by using this definition, we can understand what are the properties of a stack and what operation a stack can perform. No need to go into depth of the programming logic. What is the logic of creating a stack? What is the logic for inserting an element? It is not required presently. By using this only, we can understand what the stack and what stack operations are there. By adding all the programming part, by seeing this one only, we can understand what the stack properties and what the stack operations. So adding the details, it is only abstract data type. That's why it is an abstract data. That is the main concept. Hiding of the details, showing the necessary. That is the abstract data. Abstraction we have studied in the OOPS speeches. That is the abstract. The abstract shows only important thing. So this is the important thing about the class. The next video will discuss how to create an empty stack, how to perform the push operation. The programmatically we will see. We already know how to perform the push operation. Previous we will see. Conceptual we will discuss it. Programmatically we will discuss it. In the how to perform the pop operation, how to perform the display operation. So this is the today's class. So here I am using array. This is the array. This is the array. I take whatever the size. So this is the S is a stack that is represented using arrays. Okay. The next video we will discuss the operation.